Okay, class, we're on section 512 today, and we see a word. This is the first time we've seen this word in chapter 5. And the word is, we are now going to solve equations. Okay, we're going to solve equations, and the way we're going to solve those equations is by our good friend factoring. Now, here's how this works. This works because I can use this wonderful property called the zero product property. Now, it's the first time that we've seen this, all right? And here's what it says. In words, in words, it says, okay, it says for every real numbers A and B, if A and B equals 0, if and only if A equals 0 and B equals 0. So, a product of factors is 0 if and only if one or more of the factors is 0. Now, what Mrs. Burton likes to say is, if the whole thing equals 0, A times B equals 0, then each part equals 0. So A would equal B 0 or B would equal 0. Now, what in the world am I talking about? Well, let's look down here at my example here. This is an equation in factored form. And if you notice, the whole thing, okay, the whole thing, this is A and this is B, equals 0. So if the whole thing equals 0, then each part equals 0. So that means n minus 3 equals 0, or n minus 1 equals 0. And so we're going to use this idea of zero product property to help us solve these equations. Now, there's one thing that our book doesn't tell us until later on in the book, but I think it's important to know it now. And that's the idea that whatever our highest degree is, who remembers what's a degree? That's right, the degree is the highest exponent. Whatever our highest exponent is, that's how many answers I need. And since we're in chapter 5 and we're doing quadratic equations, then we're going to see that we're going to need 2 answers. Okay, we're going to need 2 answers because we've always got x squared. And so that's going to help us realize, oh, I need to find the answer for 2 different x's while I'm solving. Now let's apply this property and see what it means for us. Let's look up here at number 1. Now, again, the first thing we have to check when we're solving equations, number 1, it has got to equal 0. Okay, it's got to equal 0 so we can use our zero product property. Mrs. Burton calls that ZPP. So when I look at number 1, it already equals 0. Now, I would call number 1 factored form, okay? That must have had a GCF, and we factored it out, and here's the factors that remain. So remember, if the whole problem equals 0, then each part equals 0. Well, how many parts are listed? Yeah, there's a part outside the parenthesis, that's my GCF. It's going to equal 0. And then the part inside the parentheses equals 0. So now I have 2 separate equations that I need to solve. Well, we're going back to chapter 3. How do we solve equations? Mrs. Burton, isolate the variable by inverse operations. That's right. So if we look at this first equation here, what do I need to do to get x alone? Yeah, we got to divide by 2. What I do to one side, I do to the other. These cancel. What's 0 divided by 2? 0. That's right. So let's look at the second part. Okay? If x minus 20 equals 0, who's my floater? Who needs to move for me to get x alone? Yeah, the 20 does. What's my inverse operation? Add. We're going to add 20. What I do to one side, I do to the other. We're back to those properties of equality in chapter 3. So my 20s here cancel, and so we have x equals 20. Now, since there's 2 answers, you're going to give me my answers as a set. So you would say 0 and 20. Okay? So, keys, solving. We've got an equal sign. If you got an equal sign, in order for me to solve a quadratic equation, it has to equal 0. So let's look at number 2. If I look at number 2, does it equal 0? It does. How many parts are there? Yeah, there's 2 parts. So if the whole thing equals 0, then each part equals 0. So we've got 2u plus 7 equals 0. And then we've got 3u minus 1 equals 0. Now, we've got to find the answers for u. So we're just going to solve the 2 separate equations. Well, if I look up here at the first top equation, my floater is 7. I need to get rid of the 7, so my inverse operation is to subtract it. So now I've got 2u equals negative 7. And then we've got to divide both sides by 2. And we're going to get u equals negative 7/2. Now, we've got to just go down and solve the second equation here. 3u minus 1 equals 0. Who's my floater? Yeah, that 1's my floater. So we're going to do our inverse operation. We're going to add it. What we do to one side, we do to the other. And now what do we have to do to get u alone? How do we get rid of that 3? We divide. So we divide both sides by 3. And so we get u equals 1/3. And then put both of my answers in Set Builder. Okay? So the whole premise behind solving these quadratic equations is it has to equal 0. If it equals 0, then we can use the zero product property. Let's look at number 3. Well, when I look at number 3, how many parts are there? Yeah, there's 3 parts. Did you see that? Here's part number 1, that little n by itself. Here's part number 2, and here's part number 3. If the whole thing equals 0, then each part equals 0. So we've got 3 parts, so we've got 3 problems to solve. Well, that first little n equals 0, and he's done. Now, we've got 5n minus 2 equals 0. Now, let's solve the equation. Well, we've got to move that 2 over, so we use our inverse operations. 5u equals 2. And now to get u alone, we're dividing, so u equals 2/5. And we've got that third equation there. We've got 2n plus 5 equals 0. And so we've got to move that 5. The 5's my floater. We're going to subtract them to the other side, those inverse operations. And now we need to get rid of that 2 in front of n, so we're going to divide both sides by 2. So n equals negative 5/2. All right, and we're just going to put it in Set Builder. So we've got 0, and they don't have to be in numerical order, just so long all 3 of them are listed. All right, now let's look at number 4. What's the problem with number 4? It's a trinomial. There's no parts there. But I have a question for you. How can I take this trinomial and break it up into 2 parts? Yes, we're going to have to take that trinomial and we're going to have to X factor. We're going to have to factor it. Well, we're back to our honey-do list. So let's go through our factoring honey-do list. If I look at this equation, is there a GCF? Nope. How many factors are there? There's 3. Okay. Well, is that a binomial squared? No, it's not, because this guy right here isn't a perfect square. So that means if there's 3 terms, and it's not a trinomial squared, then I'm going to have to X factor. So here we go. What are my factors of k squared? K and k. What do I know about my signs? Do you remember the sign chart? If the first one's minus and the back one's plus, both of my signs are minus. What factors of 35, when I add them together, will give me 12? Yeah, we've got 5 and 7. Now, all good algebra students X factor to check the middle. So if I cross multiply here, we've got negative 7k. If I cross multiply the other side, negative 5 times k is negative 5k. And when I add them together, we get negative 12k. So the middle checked. So now we've got k minus 5 times k minus 7 equals 0. Oh, what's my next move? Now we've got it to equal 0, so now how do I solve? If the whole thing equals 0, each part equals 0. So here's part number 1 and part number 2. So that means k minus 5 equals 0. And we're going to add 5 to both sides. So we've got k equals 5. And then we'll take part number 2, which is k minus 7 equals 0. And we're going to add 7 to both sides and get k equals 7. And so my set builder would be 5 and 7. Yes, so we're going to put a lot of things that we've learned in different sections all together in section 12 and 13. Okay, so what happens if I get something like the top of my, the top problem there? Now, did you notice right away, hopefully you noticed right away, that that does not equal 0. Did you see that? And remember, I said that's the first thing we've got to check. It has to equal 0. So when I look up here, this guy does not equal 0. So I've got to make him equal 0. Well, who am I going to subtract? Yeah, that's right. So we're going to have to subtract 10r, all right? So we've got to transform the polynomial into standard form. So if I subtract 10r, now what's standard form? Remember, I need a quadratic term, which is r squared, and then the linear term goes in the middle. So I'm going to plop that negative 10r where he belongs, okay, plus 9 equals 0. So again, to get it in standard form, quadratic term, linear terms in the middle, constant terms always on the end. So if we have to rearrange the furniture to make it equal 0, make sure you put that term in where he belongs in standard form. Now that I've got that everything equals 0, now where do we go? Yeah, we've got to x factor that. So what do we know? Well, my factors of r squared are going to be r and r. What do I know about my signs? Again, the first one's minus and the second one's plus, so both of mine are going to be minus. I need factors of 9 that will somehow give me that 10 in the middle. Am I going to use 1 and 9, or am I going to use 3 and 3? Well, 1 and 9 is going to work because when I add them together, I get 10. So we've got 1 and 9. Okay, again, we're going to x factor to make sure that we check the middle to make sure we did it right. So we've got negative 9r plus negative 1r, which does equal negative 10r. Okay, so our middle checks. So we've got r minus 1, r minus 9 equals 0. Now that we factored it, okay, and we're going to use our zero product property, ZPP. If the whole thing equals 0, each part equals 0. So r minus 1 equals 0. So this r equals 1, and r minus 9 equals 0. So that second r equals 9. So our answers in set builder would be 1 and 9. Okay, so remember, most important thing when we're solving these equations is it has to equal 0. So let's look at number 1. Does number 1 equal 0? No, I got to make it equal 0. If I have to make it equal 0, who are we going to move? Yeah, let's move that 16. So I'm going to subtract 16. What I do to one side, I do to the other. So I've got 25m squared minus 16 equals 0. Okay, so now we have to factor. All right, let's go through a honey-do list. Is there a GCF? No GCF. How many terms are there? There's 2 terms. Oh, is that difference of perfect squares? Did you recognize it? It is. Okay, the first term's a perfect square. We got a minus sign in the middle. The last one's a perfect square. How do we factor difference of perfect squares? Remember, it's got to look like sum and difference or conjugates. So that means this is going to be what? 5m plus 4. And then we've got 5m minus 4 equals 0. And now use our zero product property. If the whole thing equals 0, each part equals 0. So if I have 5m plus 4 equals 0, we're going to subtract 4 to both sides. So 5m equals negative 4. And then I'm going to get that m alone, divide by 5. So m equals negative 4/5. And now I do the whole thing again, okay, to the second part. The second part is 5m minus 4 equals 0. And so we're going to add 4 to both sides. Those inverse operations. So now 5m equals 4. And once again, we've got to divide by 5 to get m alone. So m equals 4/5. So there's my two answers. Now, in Set Builder, you could say plus or minus 4/5, or you could list them separately. Let's look at problem number 2. If we look at problem number 2, and the directions still say solve, for me to solve it has to equal 0. So when I look at number 2, it does not equal 0. Who do I need to move to make that equal 0? Yeah, that's right. We're going to move that negative 1 over. So we're going to add 1 to both sides. So now I have r minus 6r squared plus 1 equals 0. Now, when I look at that, ooh, that looks kind of weird. And the other thing that I just now realized is my r squared, my quadratic term, is negative. And we want to try to rearrange the furniture where that doesn't happen. We don't know how to factor something if my quadratic term is negative. So let's go back and try it again then, because we don't want to keep that r squared negative, and let's move everybody the other way. So that means I'm going to have to move all my terms this way, okay, because I need to keep that quadratic term positive. So that means I'm going to subtract r and add 6r squared to the other side. So what does that look like? Now remember, we're going to put it in standard form. So I'm going to say 6r squared first, minus r minus 1, and now all that equals 0. So see, it's real important to make sure when we're rearranging that furniture to make it equal 0 that you keep that quadratic term positive. Okay, now that the quadratic term's positive, we've got to x factor that. What do you think? Are we going to use 6 and 1? Or are we going to do 3 and 2? Well, I'm going to try 3 and 2. Let's see what happens. We've got 3 and 2. My factors of r squared are r and r. That back one's minus, so remember our sign chart says 1 has to be plus and 1 has to be minus. And then my factors of 1 are going to be 1 and 1. So let's x factor to see if we've got everybody in the right place. Let's check our signs. 3r times negative 1 is negative 3r. 1 times 2r is positive 2r. And when I add those together, we get what? Negative r. So the middle checks. We've chosen wisely. So now we're at 3r plus 1. And then 2r minus 1 equals 0. If the whole thing equals 0, each part equals 0. So that means we've got 3r plus 1 equals 0. That's part number 1. Part number 2 is 2r minus 1 equals 0. And then we just solve those two binomials. All right? So if I look here at the first one, we're going to subtract 1 from both sides. So 3r equals negative 1. And when we divide both sides by 3, we've got negative 1/3. Over here, we're going to add 1 to both sides. So now I've got 2r equals 1. And then we're going to get r equals 1/2 when I divide both sides by 2. So when I get my Set Builder answer, we've got negative 1/3 and positive 1/2. Okay, so if you notice, we just added another step. Let's look at number 3. Well, when I look at number 3, does it equal 0? No, remember, as soon as I see solve, it's got to, I messed up. It's got to equal 0. All right, so I'm going to rearrange the furniture, and remember, we're trying to keep the quadratic term positive, so I'm going to move everybody that way. So now I've got 2y squared minus 25y minus 13 equals 0. Remember, we're using our inverse operations. So now we have to factor. Okay, we can do that. Is there a GCF? Nope. 3 terms. So we're going to say the factors of 2 are 1 and 2. Factors of y squared are y and y. That back one's minus, so one has to be plus and one has to be minus. Now, there's only one set of factors for 13. All right? So we're going to have to say 13, I keep moving that, 13 and 1. Now, I think I got my signs in the wrong place. But let's go ahead and check it out. We've got negative 1y and positive 26y. And again, like I said, I got my signs in the wrong place. That gives me 25y, but if you remember, I need negative in the middle. So let's change our signs. Let's make this one minus and this one plus, and then that's going to give me negative 26 and positive 1, and so now we're at the right place. So now we've got y minus 13, 2y plus 1 equals 0. If the whole thing equals 0, so now I got y minus 13 equals 0, so y equals 13. And then over here we've got 2y plus 1 equals 0. Remember, we're going to subtract that 1, so 2y equals negative 1, and y equals negative 1/2. So set builder then, we've got negative 1/2 and positive 13. Now, I think you see what's going on as we go through here. Let's look at the, let's go ahead and look at problem number 4. And when I look there, again, it equals 0, but I've got a factor over here. Now, what's rule number 1 of factoring? Yes, I have the GCF. What are we going to factor out? Well, if I look at the number part, we're going to factor out a 5. And if I look at the letter part, we're going to factor out x squared. What are the factors that remain? We've got 2x minus 3. Does the whole thing equal 0? Sure does. So each part equals 0. So I've got 5x squared equals 0. And if we divide both sides by 5, we've got x squared equals 0. What's the square root of 0? Yeah, x equals 0. And then 2x minus 3 equals 0. And we're going to add 3. And then we got x equals 3/2. Okay, so the whole, once again, the whole premise for everything we do is the idea of zero product property. Okay? Now, we've got 2 more problems to look at. Sorry, this screencast is kind of long. Let's look at number 5. All right, and then we won't worry about number 6. When we look at number 5, and I'm going there to factor. So when I go to factor, I look at it and I was like, rule number 1, is there a GCF? There is. We're going to factor out what? We're going to factor out a 2. We've also got to factor out an n. What are my factors that remain? Well, we're going to have n squared minus 15n plus 50 equals 0. Hopefully now you realize I can factor the trinomial. We're going to get n minus 5, n minus 10 equals 0. And here we are. If the whole thing equals 0, each part equals 0. So 2n equals 0. So that n's going to be 0. If n minus 5 equals 0, that second part, the n's going to be 5. And if I look at the third part, n minus 10 equals 0. So n equals 10. All right, class, you can start your homework.